Hello, chemists. How y'all doing today? So, Chemistry Cat's here. No, I'm not trying to poison you. Now finish your PB and jelly sandwich. PB. Why, that's lead, which is poisonous. Naughty little Chemistry Cat, trying to trick our students. We're on to you. So, everybody, the very last reaction that we are going to cover today is double replacement, and I hope you've accessed your notes so that you can write those down as we go through them. And with double replacement reactions, we have two ionic compounds. And the cations, which, as you recall, are written first, and they are positively charged, bonded to an anion, which is negative, and that's written second in the compound. While the cations in each of the compounds switch positions. So here is the general formula. We have AX plus BY, and you'll notice that the A swaps places with the B. Now A is bonded with Y, and B will take the place of A, and it will be bonded with the X. So take a look at our first example here. We have sodium hydroxide and hydrochloric acid. Now, if you recall, sodium, that is our positive ion, the hydroxides are negative. Over here, hydrogen would be our positive ion, chlorine the negative, and they just switch positions. So sodium is going to come in and be bonded with the chlorine, so we get NaCl, and the hydrogen is going to come over here and take the place where sodium was and bond with the OH group. So we get HOH. Now, HOH can also be written as H2O, and water can be written both ways. So whether you put the H2O down or the HOH as one of your products is perfectly fine, and the other product is our sodium chloride. So any coefficients that are needed on the reactant side, I will give to you. You just have to make sure that we have equal and opposite numbers of elements on the product side as well. So here, one sodium here, one chlorine on the left, one chlorine on the right, a total of two hydrogens, and one oxygen. So you see what happened there? The sodium comes over, sits in the place where hydrogen comes over, sits in the place where the sodium was. Okay, so that's what double replacement is. If we take a look at our next example, lead. Lead wants to come and sit right here where lithium is, and lithium wants to come over and sit right here where the lead is. So what's our two products? We're going to have lead bonded with a sulfate group. We have only one lead and we have only one sulfate. And our other product, notice we have two lithiums and we have two chlorine. So if lithium comes and sits right here, we want not to write Li2Cl2. What should happen with this 2? It should be pulled out and put in front. Okay, so our compound would be 2LiCl and PbSO4. Again, it doesn't matter whether you write the lithium chloride first or the lead sulfate second, as long as you have both compounds written. So go ahead and pause the video and try to work out the next example. Okay, so if you're back again, Zinc wants to come over and bond with the nitrate group. Well, there's two nitrate groups, so we do have to use a pair of parentheses and show that we in fact have those two nitrate groups over here on the product side. Now, this too also applies to Ag, which is silver. And silver wants to come and sit right here. So we've got two silvers and we've got two bromines. So that 2 gets pulled out and put in front as a coefficient. And you see how Ag is written first in this compound? Well, Ag needs to be written first in the next compound. So we get AgBr. So if you get confused at all in trying to figure out, well, which ion gets written first? Well, zinc is written first. The nitrate is written second. So zinc first, nitrate second. In this compound, the silver is written first, hence silver written first. The bromine in this compound is written second, so that comes second. So you always write the positively charged cation first, the negatively charged anion gets written second in all of these compounds. Okay, so go ahead and pause the video and give the next one a try. Okay, if you're back again, all right, the potassium wants to come in and take the place of the barium, so it is going to bond with the chlorine. How many potassiums do we have? 2. How many chlorines do we have? 2. What happens to that 2? It gets pulled out in front. Which gets written first, the potassium or the chlorine? The potassium, because it's written first here. That is your cation. Chlorine is the anion, so it gets written second. What is the second compound going to be? Well, barium wants to come and sit right here with the iodate. And we only have one barium, but how many iodates do we have? Remember, this too applies to all of the elements straight through. So if we keep the iodate together as your negatively charged anion, we have 2 of them. So we need a pair of parentheses. And we write IO3 inside those parentheses and close it and put the 2 afterward. So it doesn't matter if you write the barium iodate first or if you write the potassium chloride first, as long as you have both compounds written. So why don't you give your worksheet a try, and remember, if there's anything wrong, I highlight the area and I unsubmit it so that you can fix any errors that you made and resubmit it. And I have office hours, and you can always email me. So good luck. Hope you're all doing well and safe and secure and healthy. Same with your families. Bye-bye.